Good morning. Okay, today we'll start with some new exercise. First, I'll show you the exercise. So this is a component we need to be perform in the CAPSMILL. Okay, so this is a, a square slab is there. So I'll explain about the little dimensions. So this is a 150 square is there, and the second square is this is a 110, and we need to make the drilling, and similarly so few more drills, and the thickness of the component is 'so this is about the component like 30 mm, so depth is there. So we need to make a one more operation, that is here it is a hexagonal, this is a pocket. Okay, so it is shown here. Okay, so this is a pocket we need to perform. So while performing the each operation, I'll explain one by one. Okay, just to go through this. And this is a hole, this is just only a hole, drilling holes. This is a hole, this is a hole with one more operation. So this is a contour boring. Okay, this is about the operations we need to perform on this component. Okay, let me start with this software. Open the software. So this is a CAPSMILL. Double click on this. We will enter into the CAPSMILL software. Just we need to wait. Now we enter into the CAPSMILL. So these are some instructions we need to follow, and the same thing I'll explain. Okay, first we need to draw the path, next define the blank or draw the blank, next we need to provide the different machining operations, and finally we can see the simulation of the part, how it can be manufactured, how it is going to be, the number of operations will be performed on the component, and last we can get the NC program, that is software itself. Okay, this is about the steps to be followed. Okay, so after that we need to be create a part first. So let me start with the part. Just we need to be go with the new part, otherwise you can directly go here also. Okay, if it is window is not appeared, create a new part, or directly you can also go here also. This is a or pull down menu file, in the file also new you will get. Okay, so this is a create a new part. Okay, so after this you will get a this setup work setup window. Here units are in the minimum. In the last same exercise we have been gone through, no, same similar to that one. Units will be in the millimeter. Okay, that is a workpiece material we are considering for the manufacturing. So here we are just for the lab purpose. So we need to know about this. So when we making the operations on the particular part, we need to choose that one. Okay, this is by default, I'll select this one. So next is a work loading and unloading time. This is a time which is for the loading of the part and unloading of the part on the machine. So let it be 60 seconds, that is 1 minute, and the clearance will be as it is. There will be no need to be changed. It is an extreme, so positions were there, it is a clearance. Okay, so give OK. So after this is our part, right? So this is a square. So I'll explain about this. Okay, so go for option draw, select the shapes. Okay, select the shapes. So under that rectangle is there. Okay, so select the rectangle. If both length and width are same, that will be a square. Okay, go for a rectangle, and the first is here. This is 150, right? 150 square, and this is 110 square. Okay, both I'll consider both. First is 150. So here the length is 150, breadth is 150. So there will be no any corner radius. Let it be 0. No any angle, that is a rotation angle. Okay, so when it is comes to OK, enter. So it is asking for the point to be placed where it has to be centered. Let it be 0, 0. At the center I will keep this. Okay, so like this we got the 150 square. Next is go for option draw. Same. One more rectangle by center. So this is 110. Okay, 110. Both length and breadth will be same. So there will be no corner radius, no rotation angle. Okay. So then we got the 10 square. 0, 0 is the center. Give 0, 0. Enter. So this is what we got the, so 2 squares. Okay, again go through the problem exercise. This is it. We got the 2 squares. Next is hole. So this is a circular hole. This is a holes on a, this is a PCD, PCD of 90, and this is also circles, 4 circles. This is 1, 2, 3, 4 circles on a PCD of 130. Okay, on the 130 PCD 4 holes, on a 90 PCD, so these are 6 holes. Okay, so go for option draw. Under the draw, so here no need to be draw a circle, just it is a point is enough to make a, so drilling of a hole. So go for a draw. Under the draw, point pattern, point, that is a points on circle. So this is a PCD. Okay, fixed circle diameter. This is a PCD. So first is, that is 90 PCD and 130. Okay, this is a 90 PCD. On the 90 PCD, so what is the number of diameter? That is a 90 PCD. So number of holes is 6 holes of having 10 diameter. Okay, diameter and depth will be see later. So that is a 6 holes we require. 6 holes. And angle of first hole, if it is given, yes, it is given. See here. So this is the first hole to be, so placed 20 degree at an angle of 20 degree. It has shown here. It is given here. In the previous exercise we have not, they are not given anything in the, so about the, so this is the first hole to be, where to be placed, but in this problem, so it has to be placed to 20 degree. Okay, so in the problem it is given, so that is the first angle to be placed at an angle of 20 degree. Okay, so this is the information about the first pitch circle diameter. Okay, that is a 90 PCD, 6 number of holes, and the 20 is the first hole to be placed at an angle. Okay, so this is a pitch circle diameter. We got this. Okay, where we need to be place this, again same thing, that is a 0, 0. So place the 0, 0, enter. Okay, so we got the, so that is a 6 holes. Similar to this, so that is a 130 PCD, 4 holes. Okay, so there will be no any angle. Initial angle will be at the 0 only. This is 20 and this is on 0 itself. Okay, go for option, that is a draw. Point pattern, points on circle. Here the PCD is 130. So hole 0 itself. Number of holes is 4. Okay, give OK. So here the center is 0, 0. Place this. Okay. So this I completed. So this we completed is, that is a square we completed. So both the squares 150, 110, and this circle and this circle, and the remaining is this. So this is a shape, hexagonal shape. Okay, so what are the information given? So see here. So this is a side, having a side edge of, so that is the edge length is, or the side length is, what they are given is 30 mm. It is given, and the radius it is given. Each corners at the each edges, at each edge corner, so that is a given is radius is 10 mm. Okay, this is about the information, and this is a hexagon is, so it will be having a 6 sides. Go for option draw. Under the draw, go for a shapes. Under the shapes, polygon. Select the polygon. So what is the length of the side? It is given 30 mm. So number of sides is, this is a hexagon. Obviously it will be a number of sides is 6. And corner radius, yes, it is given. See here, the corner radius is, this is a 10 mm radius. The radius corner is, that is a 10 mm. Okay. See. So we got the, so this is a polygon, hexagonal polygon. So where it should be, the center is again 0, 0 for all the things. Okay. So this is what we require for the component, and the depth, everything it will be given in the, so machining part. Okay, this is a geometry we have created in this, right? This is everything it is here, square, circles, and the, so this is a polygon. Okay, and the remaining we will give in the machining part. So this will complete our geometry. Okay, so geometry is completed. So the remaining is, so these are the standard shapes, no need to be defined the part, it is already, so auto contour it is defined. Okay, so there will be no need to be defined. Only thing is go for option drop, define blank. Here the blank is like a raw material. So what is the maximum here? The diameter is, this is a maximum rectangle is, this is a square is 150. 150 means here it is plus 75, here it is, sorry, that is a 150 here, 150 here, plus 150 minus 150 on the minimum side. So 150 is the, this is a required. Okay, 150. If you take the same 150, so we cannot machine the part because we require the 150 on the both the sides, on the upper end and the lower end. This is the positive and the negative. The maximum is 300. So we should be considered greater than that. So then it will be, so we can machine the part, extra material. Let me consider 5 mm extra. That is the 5 mm on the plus end and the 5 mm on the negative end. Totally 10 mm. Okay. So maximum 155. Here also same. It is a square, right? So because of that, both will be same, x and y. Here it is minimum side, same it is with the negative sign. Okay, 155. So understood, the 5 mm is extra in order to machine the part extra. We need to be machine this side milling. Okay, and what is the blank thickness? The blank thickness is for our component. So required is 30 mm. If you take the same 30, we cannot machine. So we cannot do any operations like a face milling. So we need to consider extra, like a 4 to 5 mm extra we can consider depending upon the material. It will be depends. So let me take a 35. And the 0, that is a z coordinate, is exactly what we require with the negative sign. So what is the exact thickness? That is a 30 mm. So but bottom, the z will be at the bottom, so that it will be a, so if you consider this as a, this is 30 mm, so bottom it will be a, this is a negative sign. Okay, always it should be, it will be a negative, minus 30. So 30 is required thickness because of the 30, and the negative sign is because of the bottom side. Okay, so this face will be considered as 0, the top face will be considered as the, so surface it will be, z surface will be 0. So from this bottom it will be a 30 is there, so downward direction this will be a negative. Okay, define blank. Okay, 35 blank thickness. Sorry, so this is square is 150, right? Here it is 75 plus 75, here it is minus 75. Change this. Okay, so define blank. So it is the 160 I have considered, no 150, not 150, right? This is only 80, 75, 75 is there, no? So just take a 80, 80. So this is minus 80 and this is minus 80. Okay, sorry. Now, so this is a raw material. Okay. So after the defining the part and the defining the blank, so this will complete the geometry. So next we'll move towards the machining. Here we need to change the mode, machining. Go for machining. So in the machining, so we need to, so before going to give a machining the, so that is operations, we should know the sequence of operation. So here the first operation will be, so facing, so the extra material will be removed, that is the extra thickness will be removed from the top side. This is the 30 is required, so we have considered the 35, so extra 5 mm we need to be removed by using operation called as facing. So next is side milling. So this is extra material we have considered, we need to machine this. Okay, we need to machine and we need to machine this to get this, that is a shape. Later we need to make the, so drilling operation and this is drilling operation. Okay, later, so this is a boring and this is a pocket. Okay, so this is a pocket milling. These are the, so different operations we need to perform. So go for operation milling. First one is face mill. Select the tool. Okay, here it is face mill. So consider the face mill with round insert. Under that, so okay, 80 or the 100. So consider, so 8 mm diameter. So round insert I consider. Okay, okay. So select the contour which we need to be. So here we need to select this raw material. Okay, here selecting that you will get the face mill, that is a window for the face mill operation. So these are the different parameters we need to be considered, so in order to make the face milling operation. Here it has selected only face milling. So if you want, we can select the both. That is a roughing of the face milling, roughing and the finishing, both we can get. And this is a two kinds of the, that is the clearance of the material, clearance of the area of the material. So you can select the surface so clearance or the contour clearance. You can select any one. Okay, I'll select the surface. And the work surface, that it be Z. And what is the material thickness we need to remove? So we have considered here the 30 it is a required. So I have considered the, that is a blank as 35 while selecting the blank. So that it is a 5 mm extra is there. I need to remove this 5 mm. So allowance is after the roughing, so give 0.5. So that will be remained in the part. So after the roughing, so in order to get finish. Okay, so this is okay. So after this, it is asking for from the which side it has to be start the operation. Select the circle to specify the machining start point. Okay, there will be no any restriction in this. You can select either this circle or this circle. Okay. So this will compress the face mill. And next is go for the side mill. Select the side mill. So new tool. So side mill will be performed by using the, it is similar to that of the end mill. By using the end mill tools, will be perform the side mill operation. Select the end mill with flute with the 4 flutes. Select the maximum tool. Here because this is a component is huge, so that if you select the smaller one, it requires maximum time. So 40 is there. So if you need, you can select the, in the industries if it is having the more than that also you can select that. Otherwise you can select the, you can edit here also. If it is not there, just for the analysis purpose or for the simulation, you can select this, how it is going to be work. If you select the maximum, that is a diameter tool. If 40 I select, I select the contour. So this is we need to be machine. Okay, this is we need to be side mill. So select the machining starting point. From where we need to start, you can select anywhere in this. That is a square. So whole mill, yes, we need to machine whole the mill. So it will give the 2 circles. If you select the inner, so this will be make the side mill inside. So we require the side mill outside, right? Because this is extra material, we need to remove. Select this outer circle. So after that, so again you will be entering into the side mill. So again here, so if it is, there are so many operations like process, roughing process, finishing process, bottom finish. So here we are not going to make the bottom finish, only the side. Okay, so that is a rough and side finish, both we require. So let it be the work Z0. What is the material? So what is the material width? So this is a 75 75, this is a 150 square. So 75 75 is there, but we consider the 80, so that the extra is on this side. This is a 5 mm extra we have considered. So the material width is 5 mm. Side allowance, so after the roughing, so 0.5 or 1 mm you can give for the finishing operation. So bottom side we are not considered, we will select this. Okay, this is enough. So give OK. So material depth. Okay, material depth. So what is the material depth? So here it is, select PC here. So this is a first square, right? This is a first square. So what is the depth is here completely. So this is a machine, that is what is having the material width, that is a material depth completely, that is a 30 mm. We need to choose the 30. Even if it is more than that also no problem. So what happens is, if you select the exactly 30, some of the remaining parts will be shown in the, so that is a graphics sometimes, so that may remain at the, so these corners like this at the bottom of this, so that may remain. So you can select the more than that also, so there will be no problem. So because there will be no material, even 30 after the 30, so there will be no material to machine. So if you select the maximum also, there will be no problem in that. You can select more than that. Okay. So next is go for a mill, side mill. So now we need to machine this. So this is a square, right? So this is a square. Here it is. This is a totally 150 is there. This is a 110 is there. So 150 minus 110 is 40. Here the remaining is 40. This is 20. This is 20, right? Okay. Same side milling, select the already listed tool is there, select the same 40 mm tool, or you can select from the new, under the new. So end mill, so with the 4 flutes, finish 40 mm, same tool is there. Okay, select the contour. Now we need to finish this, we need to make the side milling of this part. right? Select this, specify the starting point somewhere, anywhere here in this. Yes, we need to make whole this. Select the outer circle. So what is the width is here, as I told, this is a totally 40 is there. So here 20, this is 20. The width is 20 mm. What is the depth? Okay, depth I'll tell you. Same, select the rough as well as side finish. Okay, what is the depth here? See the problem exercise. So here this is the depth, right? So this is a square. So this is a 150 square. This is a 110 square. So 110 square is only 10 mm depth, right? So we require this portion. So at a depth of 10 mm. Okay, so the depth is 10 mm. So after the allowance, let it be 0.5. Okay, understood? This is a roughing operation, side finish operation. The width is 20 mm. Here 20, here 20. Totally 40. So that is a 150 minus 110 is 40. Okay. So the depth is 10 mm. This is the only depth we require. That is 10 mm. So after this, give OK. Side finish is completed. So next is go for option. Okay. So in the milling, select the pocket. Okay, select the pocket. So select the pocket under the new tool. So you can go with the same thing, that is the end mill tool itself. So it is a maximum of 30 is there, right? This is the edge is 30. We need to select the lesser tool. If you select the 40, so it becomes a maximum tool, so that it should be less than that. Okay, so select the 20 mm. 20 mm is enough. Okay. So select the contour. This is a contour, we need to finish this, right? Here we require both. So here we require both, that is a bottom we require, side we require, because this is the inside, no? Bottom, side, everything we require with the finishing also. Okay, what is the work surface? Let it be 0. What is the pocket depth? The pocket depth is here, it is given, see here. So this is a pocket, this is a hexagon. So there is a depth of 15 mm, alright? 15 mm, okay? There is a pocket depth is 15 mm. Okay, here the side allowance, so that is 0.5. So after the roughing, so bottom allowance 0.5 allowance. So everything is over. That is the wrapping operation, bottom finish, side finish. So work surface always it will be 0 itself. So this is a depth, is a 50 mm, 0.5, 0.5, both the allowances. Okay. Give OK. Specify the starting, that is the entry and exiting point, it is asking for that. Okay, if we don't have any options, if we are not having any requirement, so by default we can select. So like this, so how the tool should be entered. So whether the tool should be entered by the line tangent, arc tangent, so like this. So if we have any requirements, we can select this, otherwise, so none directly, so it will be, tool will be come in the, so randomly, okay. Okay. So next is select the, that is under the machine, select the hole, under the hole, so drilling, okay, so this will be drilling, select the new tool. So this is a PCD, that is a 10 mm dia, 10 mm dia, 6 holes, PCD, 20 mm depth, okay. Under the drilling, select the twist drill, so the given is 10 mm, 10 mm dia, okay, 10 mm dia, select that, give OK. Select the points to be machined. So these are the machines, these are the points we need to be machined, right? Okay. Select the point to be machined. So these are the selects. Do you want to omit any holes? It is asking for, do you want to remove any holes among these 6? No. Okay, so work surface Z always it will be 0. What is the hole depth in the problem? It is given as 20 mm D. Okay, the depth is, hole depth is 20 mm. And the cutting parameters, if it is requirement, if it is given, so you can check, otherwise don't worry about this. Okay, this is the depth we required of this. Give OK. So this is a hole we have done on this circle PCD 90. So next is 130 PCD. In the 130 PCD 4 holes. So that is the diameter is dia is given here. This is also so 10 mm. So the difference is here the depth is 20 mm, but here the depth is whole depth. Okay, here the whole depth. So this is 10. This is totally it is a 30. So under the 10 is this is a portion. So here the remaining is 20. Okay, select the machine. So under the hole, so drilling. So select the same tool because there is also 10 mm, but the difference is depth. Select the points. So these are the 4 points. So select the done. You want any? So that is the exit. That is a omit. No. Okay. Work surface here. The whole depth is here the 20, but so here the through hole is it is a through hole. This is a through hole. Okay. So select the 20, or if it is more than that also there will be no problem. 22. So just what happens is the remaining part at the bottom side, if exactly take the 20, what happens is the remaining parts, that is the debris or the parts which will be so added to the at the bottom. So that wise, so you can take the more than that. There will be no any changes in that. There will be no any so changes to the problem are they to the part. Okay, 22. That is just about 20 more than 20. So completed. So next is this is a portion extra, that is a counter boring by using the counter bore. Go for machine, under the holes, select the counter bore. So counter bore, select the new tool. So what is the diameter it is? So here it is the dia is 14, right? That is a contour. There is a contour bore dia is there is a 14 dia and the depth of 10 mm. 14 mm, so diameter, and the depth is 10 mm. Select the twist drill. So the whole diameter is 14. Select the 14 dia. Okay. Select the point of the machine. So these are the 4 points. That is the 4 holes. So okay. No. So here the work surface. So what is the whole depth? So this is only for 10 mm. Right. Already diameter is chosen by the tool. The depth is only 10 mm. Okay. So this will be completes all the operation. Completed this square. There is a face milling, side milling of this outer square, side milling of this inner square. This is a pocket. This is the diameters, and this is diameter with the so these, that is a boring. Okay. So this completes the sequencing of all the operation to be performed on this so part. Okay. So this completes the machining mode, and the last is tool part. Okay. Select the comic OMC machine. So now you can see the tool part of this. So there are different coordinates we can see this x, y, y, z, zx. In the different view we can see this. So this is all the 3-dimensional view. Isometric view you can see here. Okay. This is a play to start simulation. So this will show you the sequence of operation. So this is that is a face milling to remove the extra thickness, that is the 5 mm. So it will perform both the operation like roughing and that is a finishing operation. So this is a side milling. So extra 5 mm it is removed. Here also same, that is a roughing and that is a finishing. So in the roughing operation, this is in the few steps only it is removed. So see here, this is a milling that is a finishing operation in the side mill. So it is removing the that is a minute, that is a particles. There is a minimum meter it is removing. So this will complete the. So why I have taken this is, so here. So if you take the exactly 30, what happens is the remaining part it will be, it may attach to here. So because of that, if it is more than that, so there will be no any part will be remain here. Okay, this is a second square, that is a side mill. It's a pocket. So hexagonal, that is a shape. This is a smaller PCB, that is an ND PCB, and this is boring. After the drilling, this is a boring operation. Okay, so this will complete the operation of that. Okay. So next is, that is a documentation. Under documentation you can see the details. This is a under the documents. So power graph. This is a power graph. It will show the power consumption for the different operations. Under the time study sheet you can study the complete timings of the each and every operation. Okay, so this is face milling, side milling, pocket, drill, contour, operation. This is the details about the thing. This is required for the industry's purpose. So in order to make out changes in any cutting parameters in order to reduce the total time. So this is a 147 minutes. So this is required for that component. This is a huge component, size is large. So because of that, okay. Like this. Everything details will be recorded here. Then you can see the tool list also. These are the tools we used in this. What are the tools? Okay, the total number is, that is a 6 tools. Face milling, side milling. So that is a side milling. So different, because why it is selected as different is, so here it is the side milling, same thing, but we selected second time, right? 2 times we selected. Because of that it has given the number is 3. If the same the tool is selected, so it will be give the number as 2 itself. See here, under the drilling I selected the same tool, because the number is given as 5. So this will be the documentation purpose. Okay, fine.